Hey folks, welcome back to another video. Today we are looking at question 322, coin change. The way we'll be approaching this problem is by using a method called dynamic programming. If you haven't heard of it before, I highly recommend you look into it. It's a very useful tool kit that you can have in your bag, so I highly recommend looking into it and practicing more problems on that. So let's jump right in. The TLDR version of dynamic programming is you store the results of a previous iteration so that the results for your future problems are easier to get. So basically you're storing the results for the sub problems to solve the main problem. So let's jump right in to see how we do it. The first thing that you need to do is you need to initialize an array. Let's call it dp, and then the size of the array would be amount plus 1. And this array, we will fill this up with an amount that is greater than the amount that we want. And the reason why is because in the end we can recognize whether we actually have an optimized solution or not. If we don't have an optimized solution, we can just return -1. Right, so you're filling the array dp with max, and then just before we jump into the main logic of the problem, you would want to set the index of the array dp of 0 to be 0. And the reason why you're doing that is because how many coins do you need to actually get to the amount of 0 coins, right? So that's the base setup that you need to do. So this is the base setup that we need. You need an array that will store all of the solutions, the sub-solutions, and then and you're filling it to be able to recognize whether an optimized solution is actually possible or not. And then just to set it up, the number of coins that you need to have to get to the amount of 0 is 0. So that's the reason why you're initializing dp of 0 to be 0. And after that, we will iterate through all of the numbers from 1 to the amount that we want. And while we are doing that, we will also iterate through all of the coins that we have. Right, so j is less than coins.length and increment j, right. And you're checking, hey, if the current coin that we're looking at, if it is less than or equal to I, which is the current amount that we want to get to, then we can do something. If the coin value is greater than the amount that we want to come to, it doesn't really make sense. So that's the reason why you need this if condition. And within this if condition, you say, hey, dp of I, right? So the amount that I want to get to, it will be the minimum of what we've already said previously. Or what we want to do is that we want to use the current coin and go back to something that will give us the sum equal to the current amount that we're getting at with the new coin. So what is this doing? It's like, okay, I want to use the new coin that's given to us. And then obviously to make up for the amount that I have, that I do not have with the coin, I'm going to look at that previous value. So that's the thing that you're doing right here, right? You're taking the new coin and you're saying, hey, like this is a new coin that will reduce anything. If it is more than 1, it will get reduced. And then the previous amount that we have, we might have already optimized that. So that's the reason why you're looking back and telling, hey, like look at this and add 1. And the reason why you're adding 1 is because there is a new coin that you're adding, which is coin j. So this is the entire meat of the solution. You're saying, hey, like with all of the coins that we're adding at every single point, will adding the new coin actually give us a optimized value, or do we want to keep it the same? So that's the entire meat of the solution, and that will give us the right answer. So once that is done, you just have to check in the end if dp of amount, if it is equal to the max amount, that means we weren't able to get to a solution. So you would return -1, or you would return dp of amount. Right, so let's compile this and see if it's okay. Right, so the first test case is okay. Everything else is okay as well. Awesome. So let's quickly talk about the space and the time complexity. The time complexity would be n into m, and the reason why is because you have two for loops, one iterating through 1 to the amount, and then the other one would be looping through all of the coin values that we have. And the space complexity would be of n, since we're initializing an array and storing all of the amounts in that. Perfect. So if you have any questions, please let me in the comments below. And please don't forget to subscribe. I would really, really appreciate that. And if there are any other questions on LeetCode that you want me to solve, please let me know in the comments below. I'll be more than happy to solve that for you. All right, I'll see you all in the next video. Peace.